I need a heat treatment oven. Now I've been waiting for months and I've been meaning to do this all along. I don't like starting one project when I'm still in the middle of another one, but I've wanted a shop oven for a long time now and I keep putting it off, so let's just do it. So here's some calcium silicate boards. Those are fireproof. Now somewhere in here, I must have all the other parts I collected. Ah, yeah. So what have I got for this build? 2 bits of calcium silicate board. This one's kind of a wedge-shaped piece. As you can see, it's super fireproof. Also got a piece of angle iron. Not enough to get the job finished, but good enough to start. This is kind of like the design from VegOilGuys. What have I got? I got one of those temperature control modules. Kenthal wire here. I think I got enough to make 2 spirals. Some thermocouples, 2 different ones, long and short. Solid state relay. Another solid state relay, because I got 3-phase power. I think I'll do a 2-phase oven, high temperature terminal blocks, and a micro switch for the door. So here's my plan. 200 by 200 by 300 millimeters inside, and I can just make that fit using the boards which I have, hopefully, if I calculated it correctly. Here's my wire calculation. So here I am using the VegOilGuys coil calculator. Got 230 volt power per phase. I want 10 amp per coil, 16 amp circuit breakers here, so 10 amps is conservative. The wire's 1.74 ohms per meter, and I'm using an 8mm mandrel. Each coil about 2.5 kilowatts, and I'm going to need 525 turns on the coil. Kind of hoping that that should then fit inside. Times 2. That's the idea. Let's see if it works. So first up, just cut the tapered parts. This stuff's pretty soft, cuts pretty easily with a knife. Of course it bluntens the knife really fast, but it doesn't matter. I normally just score both sides and then snap it. So that's going to be the oven base or top. Stuff's reasonably soft, but just have to be a little careful with it. But I think it's time for a mock-up. Well, I did manage to screw up my measurements here. Luckily I've got a couple of offcuts that I can cut to shape.
Tomorrow.
Einen schönen guten Morgen, meine Damen und Herren, mit einem österreichischen Servus.
Did anyone know that the Belgians have bread vending machines? Well, it's probably a little bit too thick for the x-axis, but it moves nicely. Hey Nico, in New Zealand, a biscuit is called a bicky. Yeah. Pretty sad times for aviation, huh? completely vacant shutdown terminal. Got to get through here to get to the park house. So here we can see my pieces of steel have been soaking in vinegar while I was out of the country. Hopefully that'll take the mill scale off it. I'm always amazed how useful vinegar is in the home shop. Like this was just cheap vinegar. I soaked the steel for, I guess it must have been 3 days. And the mill scale's mostly just rubbing off. It's not completely removed, a few spots still on there, but quick blast with a wire wheel and I'll be gone. Time to tack this up. Well, all the welders out there will now be laughing at me. I should have only put one tack out near the end of each piece. By doing two, it's pulled this to an acute angle, so these two bits don't fit anymore. Gonna need a bit of clamping, I guess. That's now clamped up into alignment, but it may well warp up like a Pringle once I weld it. I've got these 4 rubber feet left over from my mini lathe, so I figured I might as well recycle them on the base of this. Not the greatest fit in the world, that corner. Okay, that frame looks like it's going to work. Guess we'll see. I'm going to start making the sheet metal parts. Try putting in a bend as a cross to sort of make it look cool, strengthen it, but really it just looks crappy, so that one can go on the bottom, never to be seen again. To make up the resistance coil, I'll use the VegOilGuys simple jig. And next up, the wire guide. That should be offset slightly. It's going to be turning this way, so it wants to be offset to here. This is 1mm Canthil A, and American wire gauge I guess is 18. So I now need 425 coils. That heating coil now needs stretching. Stop it shorting, stretch it out to about twice its length. And there we have it, 2 heating coils. Each should be about just over 2 kilowatt, total of around 4.5 kilowatt heating. Not sure if you've seen these before. These are lock wire pliers. On aircraft, because it's considered uncool if all the bolts come loose due to vibration. We tend to wire them together so that one tries to tighten the other if either of them undo. So they're just pliers, but they have this locking mechanism here. So you can grip the wire and lock it, and then when you pull on it, it's got one of those old-fashioned drive mechanisms on it, and use that to make the twists in the wire. Part of this build I'm looking forward to least. I got to dig out channels in the sides and fit those coils into them. This stuff makes a bit of a mess, but hey, that's what a vacuum cleaner's for, so better get into it. Now I know some people use routers to route out these channels with fire bricks, but this calcium silicate just makes a powder that goes everywhere, so I think I'll just do this with a file. As you can see, it goes very easily. It's very soft. Alright, that's one down. Cool, lockdown finally finished here. I was able to go to the hardware store and get some more stuff for this project. In this case, it's a mortar. I'll make a watery mix, just brush some on to try and harden up the surface of the inside a little. And this soaks up water like crazy. I think I need to wet this board before I start. Next up, I've drilled some holes here and I need to make some staples. That's how I'm retaining the heater coils. Yeah, this stuff basically soaks up water like a sponge. So I've now soaked this completely. Oh man, this is hopeless. Just can't really work it. Well, this mortar really didn't work, so I'll try a different one. This one's got a bit of cement in it by the looks of it, so hopefully it'll stick better. Probably not ideal. If this one doesn't work, my last option is to put like a PVA sizing to seal up the pores of these boards. Well, this project's kind of kicking my butt. That new mortar doesn't seem to really be that much easier to work with than the other one. The real problem is this calcium silicate board. Tried doing the bottom piece, but boards just suck all the water out of the mortar and I had to take the mortar back off and try again. So now what I'm going to do, I'm going to cheat. I bought some of this stuff, kind of seals the pores. I think it's pretty much just PVA glue in water. I'm not sure what's going to happen in terms of the actual oven. Does the PVA burn out, stink? Does the sealed brick conduct heat, which you don't really want it to do? It's supposed to insulate. Got to do something because I can't glue them otherwise, at least not with this stuff. In general, I think this project not running as smoothly as I was hoping. I'm really jealous of those people who build their ovens out of K23 insulating fire bricks. That looks way simpler. I did look, but I couldn't find a vendor for those here in Europe. And since I already had this stuff, you know, you make do with what you got, huh? This back piece of sheet metal needs a cutout for the heating coils and the thermocouple to go through. Not sure if you've noticed, but shears come in left and right hand cutting. You can really only make a curve in the one direction. These are good aircraft shears. They have no serrations on the blade, so they don't make little stress concentrations. These are just cheap and nasty. Good enough for this sort of work. Bugger, I've just realised the way I've done this, I can't put this back board in with my piece of sheet metal in the way. I think it's probably easiest if I just cut the sheet metal and insert it as two pieces. Well, here we go. Time to start gluing this together. Not super confident. As with many of the things I make, they tend to end up like a jigsaw puzzle that really doesn't want to go together that well. Welding up the frame certainly strengthens everything up, covers up most of the mistakes I made. Well, I can now leave that to dry for a couple of days because I have to travel for work. Probably won't get this finished this week again. Airport, pretty much everything closed. It's all pretty spooky here, just like a ghost town. Next up, it needs a door. Looks like 30 by 25 should look about right. I made up some door hinges with slots so that I can adjust it. Right, let's glue this together and see if it actually worked, huh?
Approximately 10 hours later.
Bunch of brackets later. Here's the first of them. It's going to mount the door switch. Next up are these two parts that need to go on. That's the door latching mechanism. This should be the last major piece of welding on this oven. It's going to be the controller mount, but also it's going to be the cable run. So this is going to be the conduit, takes the power cables back to the heater elements, and also brings the thermocouple forward into the controller, which will be mounted here. And now the striker. These solid state relays should be heat sinked. Now this heat sink's obviously massive overkill, but I've had it in scrap for years, so let's lop off a piece of that. For the oven controller's housing, I'm just reusing scraps. This is total overkill, probably 4mm thick steel, but it's already got most of the shape. I'll put the heatsink down below it. I guess I'll put the controller looking something like this. Now I just need to extend this box section through here. I want to weld on some captive nuts here, so I've got these little tiny 1/16 of an inch welding rods. Let's see if I can do that without melting the nut away.
"24 hours later."
To mount these high temperature terminal blocks, I've got these little inserts, epoxy those in place. Hope they work. Not that convinced, but hey, we'll give it a go. I'm going to glue everything in with JB Weld. Not sure how effective that is for these temperatures, but I had a look in the hardware store if they had any sort of high temperature epoxies, but they had nothing.
Tomorrow for sure.
Epoxy's now dried overnight. Let's install these things. And of course, one of my inserts pulled out. Am I the only one here who constantly underestimates the space that wiring takes in? Well, that's good news. Power's up. Heating coils won't go unless the switch is clicked. I still need to finish off the handle, but it's working fine. Put that spring in it to pull it closed. So when I turn it on, it's showing ambient temperature 16 degrees and it's trying to heat to 150. Now, as it starts heating, yeah, I think I got the thermocouple wired back to front. When I wired it up, I thought, oh, it's just resistive. It doesn't matter about the polarity. Yeah, thermocouples aren't just resistive. I had a look, they do have polarity, so I need to reverse that. But it goes for a bit, then faults out sooner or later, goes out of range. There we go. So under temperature, it's out of the range. But you can see the elements were heating. You can still see a fair bit of moisture coming out of the calcium silicate boards. The whole thing looks pretty wet. So it looks like I'm going to have to just fire this at low temperatures for at least enough hours to drive all this moisture out. Here I've just been running the auto tune mode, set it for 220 degrees. It's overshot slightly. It's burning out that PVA glue stuff that I had to use inside when I was gluing this stuff together, so it's kind of smelly. I just run it for a short period, turn it off, let it cool down. Also need to drive out all the water. Once it stops steaming on me, I'll also be able to take it up to higher temperatures. I don't want to electrocute myself, so I'm going to put a metal cover over the electrics at the back of the thing. And I don't want this overheating, so I'll put some little venting on the side of it. After our basic aircraft mechanics course, my mate Anton and I got posted to the structural repair bay, or skin bay as they called it in the Air Force. I really like working with sheet metal. It's cool. Unfortunately, after my technician's course, although I requested to be sent back to a skin bay, they sent me to an engine bay and I became an engine specialist. But I've always kind of loved doing the sheet metal work. Just not as good as I'd like to be. I really need to make a couple more fingers, one 15 millimeters wide, maybe one 25, just to give me a little bit more variation. Right, well I need some sort of an insulated knob. Let's start with a block of scrap, another bit of scrap. Let's stick them together. Well, I thought this was epoxy, but it's not. Methyl methacrylate glue. Wonder if it'll work for aluminium and wood. Oh well, give it a go.
2 hours later.
What I've got here is about a 3mm gap to the door down around this corner. This is the gap that I need to address. So the second to last job I need to do is make up some more of this sort of mortar and just build up from here, tapering back to here, and from here to here. And I see I've got a piece that's broken off the top, which I'm also going to have to redo. I'm a little worried. This stuff's not very strong. I've got a feeling it's going to fall apart pretty quickly. So if you've got any ideas of a better mortar which would stick to calcium silicate, not fall apart, and be available in Europe, I'm all ears. Please add your suggestions in the comment section.
48 hours later.
Well, here we have it. The very last job I need to do on this project. I'm not typically very good at completely finishing off projects. What I tend to do is get things to about 98% finished, such that I can use the thing and then just use it. So I'm pretty happy in this case that I'm actually putting in the effort to get this thing completely finished. Yeah, big thanks to my daughter for making a cool stamp. Now you might be wondering why I put the electronics in this weird module, which kind of reminds me of Boba Fett's spaceship. I did it so that I can swivel this. There's a job I need to do where I'm gonna have to put the oven up vertically, and this way I can still control it. The switch needs adjusting after I put that cord on the door and moved the door further forward. With 4.5 kilowatt pumping into there, it heats up pretty quickly. Wee bit of smoke coming out of here. That smoke's probably from the adhesive on the door seal. Well, it only took about 5 or 6 minutes to come up to 600 degrees. I'll now turn it off, open it up, and leave it overnight, I think. Now, if anyone's curious, you don't need 600 degrees Celsius to pop popcorn. That fire cement I put on the door is really not working in the slightest. I may even just remove it completely. See if it'll seal directly between the fiberglass cord and this calcium silicate. Well, 900 degrees is about as hot as I'm ever going to need to go, I'd say. So, let's see if that works. Well, that went pretty quick. Let's see what it looks like. Well, yeah, she gets nice and warm. One of the big advantages of a process oven down in the basement is you can cook lots of nice ethnic food without the smell in the kitchen. You know, like Canadian food. Oh damn, it's supposed to be ham before cheese, huh?
Five minutes later.
And remember, boys and girls, always eat your pizza with a knife and fork. It's the rules. Thanks for watching.